All right, so let's do one more example and then we'll move to the problem at hand on our worksheet. All right, let's say we're given this triangle. All right, now here's our right angle right here. The side directly opposite the right angle is the longest side right there. Now, before I get into all that, let's say I label this angle down here as my theta, okay? Because before you can answer any of these problems here, if they ask you what is the sine of theta, what is the cosine of theta, or the tangent of theta, you first have to ask them, well, which of the angles is theta, okay? Now, I've indicated that this is my theta. If I hadn't done that, that would be the first thing you should ask is, which of the two angles is your theta? You know it's not the right angle, so it has to be one of these two. So I've indicated that our theta is this angle right here. Good?
Yeah.
All right. Now, we want to label this. Let's say that I'm going to give you some values here. This side we're told is 7 inches. We're also told that this side is a lot longer. This side is 24 inches. And we're told that the side directly opposite the right angle, which is called the hypotenuse, we're told that that side is 25 inches long. Now, the first thing we should do once we realize that this is the angle that we're talking about, and we want to find these three trig functions as they're related to this angle. What is the sine of this angle? Okay, the first thing we have to do now is label the sides. Very important. Now, we're going to label the side directly opposite this angle as op. So here's our opposite. Now, there's two sides next to this angle. One of them is the hypotenuse. So the side next to our angle in question that's not the hypotenuse is right here. What abbreviation do we use for next to?
Adjacent.
ADJ, very good, adjacent. So this side is our adjacent. And lastly, what should we label this side right here, Marco?
HYP.
Very good. The side directly opposite our right angle is always our hypotenuse. That will always be the longest side. It doesn't matter which of these two angles we're talking about. The side opposite our right angle has to be the hypotenuse. Very good. Now, Marco, the definition of the sine of an angle is opposite over hypotenuse. So apply that definition and tell me what is the sine of theta for this triangle? What number over what number?
It's 24 over 25.
Good. And there the units would cancel, so there would be no units on your answer. Because you have inches over inches, the inches would cancel, so there are no units on the answer for the side, or any of these trig functions, no units. Good? All right? Now, the definition of the cosine of an angle is the adjacent over the hypotenuse. Keep these three trig definitions handy when you do your problems. What number over what number for the cosine of theta in this problem?
It's 7 over 25.
Very good. And lastly, we need to find the tangent of theta. And again, the definition of tangent is opposite over adjacent. This is the only one of the three that doesn't have the hypotenuse in the denominator. Okay? So what number over what number for the answer for the tangent of theta for this problem?
It's 24 over 7.
Good. The opposite, oh wait, over the adjacent. Perfect. 24 over 7. Good job. Very good. Now, these are your three trig main definitions. Again, you always want to know which of the angles we're talking about before we can label our sides. Because why? Because if I'd been given this problem, a different problem, okay? Let's say I'd been given this triangle here, and we had similar numbers. We were told that this side was 7 inches, this side was 24 inches, and this side here was 25 inches, okay? And in order to do this problem, Marco, What is the sine of theta for this triangle? Can you tell me as it is?
I can't,
Why not?
because I don't know where theta is.
Say it again louder.
I don't know where theta is.
That's a perfect answer. Yeah, before you can go to the definitions, they have to tell you, well, which angle are we talking about? So let's say I'm talking about theta being up here for this next example, okay? Once we know which side, which angle theta is, then we can define our sides in reference to the location from theta. That's the key here. It's a referencing and location to problem. All right? So, which side is directly opposite theta?
7.
7 inches?
Yes.
So I'm going to label that opposite. Which side is next to this angle but not the hypotenuse?
24 inches.
I'm going to label that the adjacent. And lastly, our right angle is right here. We see it wasn't labeled, but there it is. Which side is directly opposite the right angle that we're going to label the what?
The hypotenuse.
Which is this side right here. Directly opposite the right angle is your hypotenuse. Good job. Now, for this particular triangle, what is the sine of theta?
It's 7 over 25.
Opposite over hypotenuse. Good. What is the cosine of our angle?
It's 24 over 25.
Good. And lastly, what is the tangent of theta?
It's 7 over 24.
Okay, opposite over adjacent. Opposite over adjacent. Perfect. Good job, Marco. All right. Now, there are 6 trig functions altogether. I'm going to put down the other 3 trig functions now, but these are your main trig functions. These are the ones that we'll be working with 90% of the time, I would say. 82%, whatever. Most of the time, we'll be using these 3 main trig functions. The other 3 main trig functions, the other 3 trig functions are easy, but once you have these, then you can get the other 3. Because the other 3 are the reciprocals of these 3. Do you know what a reciprocal is?
Yeah.
That's when you, well, I wouldn't say opposite, that's when you flip the fraction.
Yes.
Okay, so these are the 3 main trig functions. Let's put down the other 3. All right, the first of the other 3 trig functions is going to be the reciprocal of the sine function. Okay, now the reciprocal of the sine function is called the cosecant.
Let me stop you, Doug.
Yes.